In lesson 92, we're going to look at what's called boat in the river problems. And really all they are is distance problems. And remember our formula for distance is distance equals rate times time. All we're going to do is look at the rate a little bit. We're going to add two little variables for the rate. Okay. We have a downstream rate. Okay, so say we're traveling in a boat and the boat is going downstream. Well, what does that mean? It's going faster, right? So your speed would be, since your speed would be faster, your two variables are going to be boat and water, because those are, you got a water and boat when you're, going downstream. So if we have a downstream rate, that would be boat plus water. If we have an upstream rate, you're going against the current, you'd be slower, so that'd be boat minus water. So how we plug all these in is it's going to look something like distance equals, instead of R, say we have a downstream problem. Okay? Say we have a downstream problem. It'd be distance equals B plus W times your time. So we're just switching R with either B plus W or B minus W. That's all we're doing. So now let's look at an equation, or a problem. Example 1 says Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. All right, let's hold it right there. We got two different equations. We got the 60 miles and the 20 miles. Those are distance. All right, so we're going to have, I'm going to call it equation A and equation B. In equation A, I know my distance is 60. What else do I know? They could go 60 miles downstream. Okay, well, downstream means we plug in B plus W for my rate. Okay, I'm going to put a T there for time right now, because that's what we know so far. And the same time, so what is same time? That tells us our times are equal, okay, in our two equations. It took them to go 20 miles, 20 for my due distance, downstream, all right? So B minus W, since it's downstream, times are the same, so I keep the same variable. So here's my, upstream. Here's my upstream equation, and here's my downstream equation, in a sense. Now let's continue reading. If the speed of their boat was 8 miles per hour, all right, so boat means equals, was 8 miles per hour. So we're going to plug in 8 for wherever a B is. So this B, we're going to turn to an 8. All right. So we have 60 equals 8 plus W, and 20 equals 8 minus W times T. It says in still water, so that means the water is the same. It's not moving. What was the speed of the current and what were their times? So we want to know the speed of the current, that means the water, and the time. Speed. I'll get to W in a second. But what was the speed of the current and the rate and their times? So from here we just solve. So what's going to happen is distribute those. Distribute here. So that's going to be, I'm going to try to keep it out of the glare, 60 equals 8T plus WT, and then 20 equals 8T minus WT. So there's our two equations. Now, if you notice here, these can eliminate the WT. They're opposite, so we can cross those out, add these together. 80 equals 16T, and now we can know our time. We divide by 16, time, all right, time equals 5. Time equals 5. So there's one answer. Now we got to find the W, so all we got to do to find W is plug it into either one of these equations. I'm going to plug it into this one. 60 equals 8 times 5 plus W times 5. or 5W, whatever you want to call it. So this becomes 40. Subtract 40. That's 20 equals 5W. So the speed of the water would be 4. So those would be your two answers. I said in still water earlier, it said if the speed of their boat was 8 miles per hour in still water. That didn't tell us the W was actually still. It just told us that's how fast the boat would go when the water was still, when it didn't have any current against it or for it. But anyways, just wanted to explain that. But that is how you do boat in the river problems. Just distance problems, just plugging in B plus W for downstream or B minus W for upstream.